So welcome to GPSTEC309. This talk is technically a part of the Global Partner Summit, but that does not mean that you had to be a partner to be in here. So some of you might be customers, I'm going to ask in a second, as well as some of you might be partners of AWS, and might have worked with you in the past, hopefully. Basically, this talk is going to be on day 2 operations of Kubernetes. There's a little bit more that I'm actually going to be talking about here than just day 2. I'm really going to be talking from the perspective of what can you actually do to make your operations of Kubernetes in general better? And some of this is also going to be called actions to some of the partners in the room to say, hey, there's some really neat abstractions for Kubernetes that you can actually start utilizing. And I'll talk about one where I'm actually doing that in an open source project. And that's about it. We'll also talk about Flux. You heard Abby and Claire and Jess talking about GitOps in another talk. I'm also going to be talking about that, and specifically in Kubernetes, a tool that makes it dead simple to do GitOps. I'm going to be talking about operators. I'm going to be talking about some security stuff, and then I have 2 demos mixed throughout the whole presentation. So hopefully my computer doesn't shut down, and hopefully the internet works because I'm fun and I like to go off Wi-Fi. So a little background about myself. I'm Chris Hine. I'm a partner solutions architect here at AWS. And pretty much I slice across the entire container ecosystem. So that means I work with partners like Mesosphere and Docker. I used to work with CoreOS. Now I work with Red Hat from that side of things. I also work with some of the CI/CD partners, a lot around the container space, and basically make sure and work with those partners to make sure that they're using the latest technologies, helping them to actually implement some of these new structures like what I'm going to be talking about. And outside of that, I'm an open source contributor. So I work on a bunch of open source projects around the Kubernetes landscape, namely for AWS. I've worked heavily on the AWS IAM Authenticator. So if you have questions about any of those tools that you use, also have new contributions to the CNI plugin as of a couple weeks ago that I'm doing some new work there, and have an open source project that'll be coming out soon around that. Before we actually get started, I'm going to ask a couple quick questions, which I have a slide on. So first question, before we jump into my other slides, how many of you, or raise your hand if you're a partner or from like the partner ecosystem with AWS? Cool. So there's going to be some call outs for you guys. How many of you are just customers and just using Kubernetes, or actually no, just customers first? Awesome. How many are actually working with Kubernetes currently? How many are working with Kubernetes just on EC2? So things like COPS or kubeadm or, awesome. How many of you, and keep those hands up on this one as well. Keep your hand up if you're also doing EKS. OK, now take your hands down if you're only doing EKS. Cool. All right, that sounds good. So for those of you, I'm going to start with this because this is just my obligatory slide. So what is this? I want somebody to actually answer. Like I said, I'm going to call out and make sure that you guys are talking so you're engaging in this, because I want you to be a part of this. So somebody give me an answer for what this is. Fantastic. Thank you. All right, that's my little troll for you guys. Now, somebody else or multiple people, what is Kubernetes? How do you define Kubernetes? It's a what? It's a pilot, OK. It's an orchestrator, OK. What else? A framework. All right, cool. So the way that I like to define it is these 3 things. We typically, at AWS, call it an open source container management platform that helps you run containers at scale. It also gives you primitives for building modern-day 12-factor applications. And I specifically am calling out that, or I'm crossing out that container because I like to think of it as actually just an open source management platform, being very abstract here, because it doesn't just have to be containers. Is anybody actually in the audience using operators currently? Nobody? Oh, one person. Fantastic. Thanks for waving your hand. Awesome. So there's a lot of really cool stuff that you can actually get out of Kubernetes that most people aren't. As we see from the audience, there's only one person in here that's using an operator. And I'll dive into what those are in a little bit. So what does it actually mean to be what I just said? It's an open source management platform, and it helps you run containers at scale, but also run other things at scale. So what does this actually mean? It's an API. You all have experienced this, or those of you that have actually worked with Kubernetes, you've experienced this. It's just an API behind the scenes. That API has some other components, and it's a microservice architecture that makes this all possible. But what it really does is you can actually just see it by actually using a -v equals 7 or 8 or 9, and you can actually see the actual request that you're making to the Kubernetes API server when you're doing this. And what I'm really trying to get across is it's nothing different than what you're already building. You're building applications, well, most of you are probably building web applications on top of containers and deploying it into Kubernetes. So it's no different than that. And from the open source perspective, this is a big call out, because I feel like there's a lot of people that are kind of scared to get into the community, scared to actually start contributing, and scared to go through that, or maybe they're just not sure where. It's just an API. You already are doing this. And in this instance, it's a JSON API, and we have some custom headers in here that make it so that it will render properly for kubectl. You have some other parameters that are getting passed through, but it's just an API. That's not scary, right? It's pretty easy. Continuing that forward, if you've ever run kube proxy, you've seen and loaded up that 8081 endpoint on localhost, you'll see something that looks like this with a ton more requests. It's just an API. It's just a REST API. Yeah, sure, there's some gRPC behind the scenes, and yeah, there's a scheduler, and yeah, there's the kube controller manager, but it's just an API. Let's start with that. Now, what are those things that you're actually seeing? You're seeing Kubernetes objects. In Kubernetes objects, this is all just pulled directly from the documentation because they have the best way of defining it. Kubernetes object is a record of intent. It persists entities in the Kubernetes system. We'll call that etcd. And then it helps you to marshal the desired state of your cluster. And these are some of the resources that it actually exposes to you. If you looked at that kube proxy localhost 8081, you'd see a lot more of these things like the admission controllers that were in that last call out, and then anything else you actually tell it to do, because you can extend it. And that's where it gets really fun. So beyond the API server, there's the scheduler. And raise your hand if you've worked with schedulers besides Kubernetes. Things like Mesos, anything? Cool, a lot of you have. So this is a typical workflow of a scheduler. And this is all centered around what we call the control loop. And the beginning of this is, or some of that is coined from things like robotics. And it brought on this new motion. Things like Mesos really started to solidify that state that we actually have. So what you do in Kubernetes is you basically have a state. That state is stored in etcd. And you have a process that's sitting there and doing something else. It's auditing it. And that's what we're really getting in here. And we have that audit. And then it steps on to the next bucket, which is reconcile. And this is all we're really doing, but hundreds of thousands of times across your cluster. It's just continuously doing this and making sure that things are in that desired state. This is why you get some of those declarative and self-healing technologies that we get out of Kubernetes. And it just, again, continues that loop through and through and through. Schedulers are pretty awesome, because now it's automating everything, and I don't have to do any of that stuff. I don't have to sit there and check and see if my chef scripts are up to date or check my drift or whatever you want to call it in this world. I can just tell Kubernetes I want it, store the state, have it audit it, have it reconcile it, and I can do that for not just those Kubernetes objects, which is, again, what I'll talk about a little bit later. Is this making sense so far? Cool. I got a lot of nods. So what are some of the benefits of this? Probably already know this. A lot of you already start running Kubernetes. It gives you immutable infrastructure as well as immutable anything realistically. It gives you, everything is declarative. You tell the state store what you want it to be. It'll make that happen. And it's just going to continue to do that. And then the last, it's going to be self-healing because of that reconciliation loop or the control loop. So what are we talking about with day 2? Day 2 is an interesting thing. If you think about it from I think I actually have the slide. Yeah. So what is day 2 operations? So day 0 is really when you're going through, and most of you have already done this, gone through and set up requirements. You talk to your developers, you talk to your operations team, you talk to the security teams, you said, okay, what do you need out of this cluster? What is it going to have in it? Is it going to be a production cluster and it has everything thrown in it? And maybe, I don't know, how are we going to do segregation? How are we going to isolate our workloads? How are we going to do security? How are we going to kind of thinking through some of those processes up front, right? Then you're going to do your architecture for it. Now with Kubernetes, this, in my opinion, gets really simple. I'm going to deploy containers. Containers are my portable object. I'm going to throw those wherever I want. Maybe I'll throw some other things in there if you get into operators like that one person. And then you're going to have some sketched out designs. And then you're going to move into day 1. And day 1 is where you're actually going to start doing things. So you're going to go and install a cluster. Who here has actually used just CloudFormation to deploy your clusters? Cool. How many of you use Terraform to deploy your clusters? A lot. Cool. How many of you use EKS Cuddle? 1, 2, 3. OK, cool. How many are using like COPS when they're actually in the? OK, cool. Fantastic. So this is the installation and setup and configuration phase. You're going to go through and do all of that. You're going to start deploying the cluster. You're going to start figuring out how you're going to do security across your cluster. Maybe you're instilling things like network policy controllers using Calico or any of the other providers. You're going through and saying, all right, if I'm my configuration for how I'm going to actually give developers access to this, or maybe I'm not going to give developers access to this, and how you want to actually make that possible. Now, day two, we're going to be talking a little bit deeper. What is real security that we're going to have set up here? How are we going to scale this? How are we going to do CI/CD? And I have that ... because I want to also talk about what else we can do. Again, this is that call out towards the partners. Like, there's a lot of really fun stuff that we can do because we have that scheduler loop. And that thing can be extended. How many of you are familiar with CRDs, or custom resource definitions? Can somebody tell me what it is? One of those people that raised their hand? What is a CRD? How would you define it? What does that do for you? Cool. Did everybody hear that? All right. So what it does is it allows you to extend the Kubernetes API server and give it new objects that you've defined. Not just a pod, not just a deployment, not just a replica set, not just a service, not just a so on and so forth. You could tell it whatever you want. I want to deploy foo into my cluster and have it manage foo. I could do that. I can model an object using YAML, just like I model my other objects. Tell it I want to manage these things, or I want the API server to be able to store those things, kind of like a migration, kind of like telling your Postgres database, hey, I want to manage this new table of resources. That's what you do. You define it in YAML, and you kubectl apply that file. It has a special kind of custom resource definition. And then you can actually then set up tools to then build the control loop for those objects. So what does Kubernetes give you? As I already talked about, it is a platform. It is a platform that allows you to build a lot of things on top of it. Anything. I've basically left these blocks completely blank because you could do whatever you want, in my opinion. And I technically do this. I like to make Kubernetes manage a lot for myself. I'm currently in the process of building out how I would, just for kicks, how I would manage all of my IoT products across my house. I am a huge Alexa fan, and I throw everything in there. But I've been actually building out new microcontrollers that actually do other functions that I don't have tools for. And I've been modeling those objects as CRDs so that I could then apply them to the cluster and have Kubernetes be my control loop in my house. It's pretty awesome. So you can do anything you want with this thing. So what we're going to be talking about in this day 2 stuff. So we're going to talk about GitOps, or in configuration as code. We're going to be talking about building for failure. That's where we're going to be talking about operators. And security being day 0. I call it day 0 even though we're talking about day 2, because I still find that as I talk to customers, they're not doing this. And so I want to make sure there's a couple easy things that we can start with that fall into the same buckets that we have here. Building for failure, using the control loop, a little bit around GitOps. All of these things can also be baked into that. So even though it's day 0 there, I'm talking about it in a day 2. How many people are actually doing, wow. Yeah, how many people want to raise their hand and say they are, you are using a security tool that's actually managing your current cluster? Sitting there, scanning images, maybe at runtime, or maybe you're just doing it at build. There's very few hands. Cool. See what I mean? It's not day 0, but it also is day 0. You should have been doing this. There's a lot of really good stuff here that you should be playing with that can help secure your clusters. I don't care if you're a completely private cluster and behind the scenes, nobody has access to it. You should still be doing this. You have vulnerabilities that come out in a lot of these tools, and it's very important to make sure that you protect your customers' data and protect your own resources. Cool. So first thing we're going to be talking about, configuration as code, which I really like to call it configuration is code. Because it is. It should be managed just like you manage all of your other code. So how many people actually put all of their YAML manifest files in a, raise your hand if you put your YAML manifest files or Helm charts in a Git repository and have some tool that is then applying those to your cluster? Cool, you're all doing CI/CD. How many people are using Flux? All right, cool. So are you using just like a Jenkins process? Or raise your hand if you're using like Jenkins to actually manage that for you, or a code pipeline, any of those. OK, cool. Sweet. So I'm going to give you a quick demo in a little bit that talks about just Flux in general and what Flux does. Flux is a really cool tool. Oh, sorry, I forgot that I was actually talking about this first. So what we're actually first going to go into is configuration as code from the actual cluster perspective. So if you're not familiar, AWS CloudFormation, you can export these things from COPS. It is a standard provisioning tool for managing your clusters. We have primitives for EKS clusters. If you use COPS to just deploy your clusters in itself, you can actually export these and then put those in a Git repository and manage them from that perspective. We also have Terraform that you can do this with. So this is a simple definition of what that same CloudFormation script would look like in Terraform. Another standard provisioning tool, we had this at launch, day 0 launch of EKS for full support for deploying clusters. And it's another great way of deploying it. We saw a handful of hands come up about using this already. And now we're going to talk about GitOps. Sorry about that. So I wanted to start with grounding this a little bit. How many people use something like Hubot in their clusters or in their environments? Cool. All right. How many use something like, or how many people do ChatOps currently? You're able to talk to something and have it deploy resources for you, do any of that? Cool. All right. Well, I want to replace those because I don't want humans doing this anymore. I want to talk about GitOps completely. So I think of this as basically a way to replace that entire service and say, hey, instead of having a human still controlling those accesses and basically saying, I want to deploy this to some specific location that some other person could then come in and say, hey, wait, I want to actually deploy to that. And being able to override, yeah, you can put locks in place, but being able to override those things, think about it from a different perspective. Use Git as a source of truth. It's already a source of truth for what you do for all of your code. Start throwing your manifest in there and use pull requests to manage it. We have a perfectly great audit log. We can even sign commits to make sure that they are from the exact person that came through. There's a lot of really fun tools in there. If you haven't done git commit capital S to actually sign your commits and maybe even do a DCO, developer origin, basically you can actually have verification of who is doing these actions and then have Git manage that and have it completely distributed. It's a fantastic tool for this environment. So what is GitOps? It basically means that you're putting all of your manifests in a Git repository, and then you're setting up some processy, a CI/CD tool, Flux. There's a handful of other ones. I'm really excited to play with GitHub Actions when that fully comes out to be able to actually implement this as well. But what it's really doing is doing exactly this. You have a developer. You commit those manifest files to a Git repository. You have, in this instance, Jenkins going and doing things like all of your automated testing. And then you're pushing a new Docker build. And that new Docker build is then triggering Weave Flux to go and deploy that in your cluster. And now you have what sort of feels like a little bit of a reconciliation loop directly happening from GitHub or from whatever your SVN is. And it's pretty nice. I'm going to continue to beat this, the topic around schedulers and control loops because they make your life so much easier. So in this instance, we use, I'm going to demo Flux and basically show how this can actually be used to do it. My computer's about to shut off. Cool. Again, everybody can see this, right, in the back? Hands up? Cool. All right. So really fancy thing. I'm not doing the full Jenkins flow here, but basically I'm using Cloud9 to do all of my development. I recently shifted over to this, and it's been really fantastic. I have an EC2 instance that's somewhere else, not on my local machine, that saves my state. If you haven't played with it, you really should. It's pretty fantastic. I also package it into an Electron app so I can have it as a local app, which makes it feel like an IDE. Anyway, so what we have in here is we basically have a Git repository. This is just, there's no commits on it currently. In here, what I actually have as well is a cluster that has get all-n Flux, is I have a cluster that has Flux deployed into it. And it's specifically looking for Helm releases. So in my instance, here's my Helm operator that's going through, the Flux Helm operator. It uses memcache as a backend to store some of the state in there. And what we actually do here is we can go through this Git repository and see one of these releases. This is what a release looks like. And this is actually a custom resource definition. So how I was talking about at the beginning, and I got a great definition from the audience, this is what a custom resource definition looks like when it really gets realized. You have an API version that isn't k8s.io. You have flux.weave.works, v1 beta 1. Your kind is a Helm release. Kubernetes doesn't know about it until you tell it to know about that. And in there, it has the standard components, just the actual same object that all other Kubernetes resources work with, that metadata. So you specify a name, the namespace that you want it to deploy to. You want it to be automated. You want it to have a chart version. And then you want to set up the release name for it for the Helm part. You're also passing in any parameters you want. And so now that values file that you would typically manage through a Git file, you actually have a CRD that gets then deployed to a cluster. And anybody else could then pull this down and know exactly what you applied. So now, in this instance, I have this as a source of truth there, but it's also being stored in my GitHub repository. So in this instance, just to show you a quick demo of how this works, I'm going to go through and say change version to 3, because that's the simplest update I can do on this MongoDB chart. And I'm going to say git status. So I have updated that release. Let me pull it to the top for you. And I'm going to go add this to the repository, git commit -s. Ooh, Wi-Fi's getting slow. -m. And this is updating from x.x. To x.3. And then I'm going to do git pf. Some of these aliases are just pf specifically in my environment is push force with lease. I'm a very big fan of making sure that your history looks beautiful. So I always use my pf command. So now what actually happened is if I actually go and list these, I can actually do, I think it's a search through this. And I'm going to go to the next one. Nope. kubectl get -n demo, and then go deploy MongoDB. And this is actually supposed to be described. And you'll see in here, as we describe this, that after a couple seconds, my image gets updated. Oh. Pod, MongoDB. So you should see that, why am I not getting my cool. So 58 seconds ago, I'm just going to show it that way. 58 seconds ago, that pod was re-rolled, and there's a new instance of the image that got deployed, and it updated that, and that state is still stored in Git. And anytime I want, I can go do this again and basically update this to 4 and do that exact same push. So if we go put that, and then go git add period, git commit -s-m, and say x.x.4, and then git pf. We can push that. And then I'm going to do, now instead, just to show it all actually operating, we can do -w. And you'll see that in a second, what's going to happen is I'm just basically periodically checking. Now it's terminating. Now I have a pending pod. And then there's an error poll, because I shouldn't have updated to 4, apparently, because there isn't a 4 version. But basically, that operation now is allowing it to automatically deploy that and reconcile the state that it should be at. That's pretty nice. Cool. So that was Flux. Flux is a really nice tool. Again, what it looks like is it's going through this exact same workflow where you're pushing to Git, having something run test, building an image, and then deploying that and making sure that the state actually gets stored in a place that is easily committable and easily actionable on. So now we're going to be talking about using the control loop to build for failure. the scheduler. And this is one of my favorite topics to actually talk about. So remember this. So this is state, audit, reconcile, and that continued loop. So you go through this flow, and this is what, where is this actually used? This is used everywhere. How many people are familiar with the Kube Controller Manager? Cool. So internally, all of those resources, all of those controllers are doing that exact same reconciliation loop. So anytime you get a pod and you deploy it, a pod was one of those resources. Each one of those is using a control loop of its own. And it's sitting there and doing that reconciliation. So it's a very well-known and well-used component in Kubernetes. It's a part of the core. And how can you use this? So you can actually use this by looking at things like operators. So I'm going to call out this is like a shameless plug for my own tool. So I started building the AWS Service Operator, which allows you to actually manage AWS services directly via kubectl. So you never have to leave kubectl. You never have to leave YAML manifest files, because everybody likes to bury themselves in YAML. And you can model all of your resources, never using CloudFormation, never doing any of that stuff, all using the AWS Service Operator. So you can go through and say, I need my application to have a DynamoDB table, and model that application. And I'll give you an exact example of that in a second. And have that deployed into the cluster by using kubectl or using Flux to actually deploy those resources. It's also used by other operators. So these are the two, a couple of the first operators. This term was coined by CoreOS, actually. And this was the etcd operator, which allows you to deploy an etcd instance into your cluster, or multiple instances into your cluster. And same with Prometheus as well. You can do these through operators, which just look like pods in your cluster, but have CRDs that back them. How many people are actually using, well, no, there's only one person. What operator are you using? Which one? Ah, for Kafka. OK, cool. So there's a Kafka operator out there. I also was talking to a partner, Dynatrace, earlier. They said that they have an operator as well. I haven't played with it yet. But to do all of the monitoring within your cluster, you could deploy the Dynatrace operator and have that work for you. And what these are is they're just a pod with some CRDs that back them that allow them to do this. So I threw two terms, though, that gets really confusing here. So I threw controllers, and then I threw operators in there. So what is an operator? And I have constantly struggled with this definition, because I find that the core uses the core uses controllers, but outside we use operator terms, which feels a little bit weird to me, if I'm being completely honest. But I was talking to Chris Nova earlier this week, and this was her definition. And I kind of like it. Operators are domain specific. So if you think about what I was telling you about with the AWS Service Operator, if you were to take that and basically abstract away any AWS-specific functions, you could call that a controller. But when it's specific to that resource, you can call it an operator, which is kind of nice. So that gives you a little bit more of a definition of what I'm talking about with operators in general. So I'm going to quickly demo the AWS Service Operator to give you a nice preview of how this stuff can work for you. And if I switch back to my two. So this is an example of the AWS Service Operator. Up here, we basically have, there's two manifest files on the screen, and I'll show you the third one in a second, or resource. So we have the Service Operator API version. It has a DynamoDB table, or it's a kind of DynamoDB table. The name that we're actually calling it is DynamoDB table. And the spec, if you're familiar with Dynamo resources, we have the hash attributes that you define on your table. We have the range attributes that you're defined on your table, and the read and write capacity. So all of that just looks like YAML, just looks like a Kubernetes resource. Does that make sense so far? I'm not getting any action. All right. So in here, we also, because this manifest is a nice quick little demo of how this stuff can work, we also have a service. And that service is just a load balancer to actually do ingress into the resource. And then we have a very, very, very dead simple deployment. And it's deploying a Dynamo app. You can see the container down here near the bottom. And it references a couple environment variables that allow it to connect directly into the table. So you could think of this in any representation, like an RDS database, having the table name being passed through. But as I said, there's only 3 manifests in here, and I'm referencing this config map that is called DynamoDB table. Now, if you're paying attention at the top, I called that CRD actually, or the Dynamo resource, a Dynamo table as well. And what's really nice here is the operator does some fancy things where it'll go through, when you pass in the object, the Dynamo resource, it'll go and deploy that for you, start provisioning it, and it will, when it actually is fully provisioned, I'll get a notification, or the operator will get a notification back in itself, and you can actually trigger other things. So I'm actually triggering it to write all of the outputs from, sorry, I didn't give you a little definition here. What happens behind the scenes is the operator is actually deploying CloudFormation stacks. And that CloudFormation stack has a bunch of outputs on it, all of the information that you would want from a DynamoDB table. And it takes those outputs and writes it to that config map. And that config map, then I can reference it and have it immediately boot the pod when that's available. So I have like this pseudo dependency tree throughout my whole architecture, which makes this really nice. So if I went through and actually deployed this, let me show you first. So if we do get cm, you'll see that there's no config maps in here. I'll do kubectl just to give you the full pod. Not going to have any pods in here. I'm just doing this in the default namespace. My other stuff was not. And I do, just for the sake of time, I already deployed my load balancer just so that I could actually preview that after it works, because it does take some time, as most of you probably know, to get the ELB provision and also automatically hooked up to the pod. So if I'm in here, I can actually do kubectl apply -f on this resource, DynamoDB app. And you'll see that resource in there, the Dynamo Service Operator. And I can do kubectl get Dynamo. And I have tab completion on to make it a little bit easier. But you can see that DynamoDB table. I'm going to then do -o YAML and -w to watch it. So what's really cool here is because I'm using CloudFormation and because it's provisioning, I have a status key that's giving me the current up-to-date status of what's going on in here. So anytime I get an event that you would typically see in the CloudFormation console, you get that event here. So it's create in progress. You'll see that the resource creation was initialized. Here's my stack ID that I can reference to. But just from here, I don't ever have to actually leave this console. I can also, because those events are coming through, I get events about them. And I'm storing those as standard Kubernetes events, if you're familiar with those. So you'll notice that it just went into a create complete. And what I'm going to do is get those CMs again. So now I have a config map. And because of that, I now can get pods. And you'll see my pod is now in a running state. And it's backed by, which I should have given it some more time. There we go. It's backed by DynamoDB. So basically what this application does is it creates a DynamoDB table, or sorry, the operator creates the DynamoDB table. Then the application, when it deploys, it goes through and says, it will go and check to see if a key exists. If a key doesn't exist, it writes it. And this is just some blank text that I wrote in here about the operator a while back. So it's pretty nice. You can actually do 100% from kubectl all of your management. And right now, there's about 7 resources that are actually supported. I think this will be very interesting from the partner perspective to also talk to everybody, because there's some really interesting tools here that you automatically deploy. So think about maybe you're deploying an SVN into your own cluster. Maybe use GitLab or something like that. That has to be backed by a data store. But you now, when you actually deploy those solutions, you have to go and actually deploy an RDS database. Or maybe you live in the Wild West and you want to deploy a Postgres database onto your cluster. This won't solve that. But if you want to back that by something in AWS, you could use the operator to then manage those resources for you. As of right now, as I said, it deploys about 7 resources. I'm in the process, actually, of code generating all of our CloudFormation resources into this. So you'd be able to kubectl apply any sort of resource. You could deploy a subnet. You could deploy a node group. You could extend your Kubernetes cluster. You could extend your VPC. All of those functions directly from kubectl, just like you do with your application stack. It's very nice. Yeah, so that's the operator. I'm going to flip back to the slides. And then we're going to talk about security for a little bit. Cool. Does anybody have any questions about anything we've covered so far? Or about the operator? Yeah. From your perspective, no. In the code, it does. In the code, right now in the code, you can actually go look at it. It's 100% open source on GitHub. It's at AWS Labs, and it's AWS-Service Operator. Inside there, there's a bunch of model files, and those model files reference the translation between CloudFormation and CRDs. In the newer version, it will be a direct translation, and then we'll have these layer 2 services that allow you to do more custom things built on top of it. Some of the CloudFormation templates are actually very similar to those. They're just extended a little bit to be a little bit more batteries included. Yeah, so it's very similar to the functions there. So the service broker has a different architecture behind the scenes. Because I'm actually using CRDs in itself, I have a little bit more functions that I can actually build on top of it. The service broker has 3 APIs that you adhere to, things like bind, service instances, and I forget what the other one is. And those APIs are list is the catalog. And those APIs are very somewhat restrictive, at least. And so this gives you the ability to actually use core native Kubernetes functions. So things like RBAC, which aren't supported at all in the service broker today, are fully supported because I'm actually able to use Kubernetes RBAC to gate who can create these resources. There's another question in that. Oh, cool. Fantastic. Yeah, one here. So right now, there's a couple things. So right now, you can deploy, when you deploy this, I'm deploying it onto a specific node that has full access to do that and not putting anything else on there. We do have, from the community perspective, there's a KEP out there. If you're not familiar with KEPs, that's the way that Kubernetes does improvements or extensions. Basically, we have a KEP that we started working on with the community around how to do pod identity. So there's tools, there's other tools out in the community that do this. We've been looking at how we want to solve it. So there's a full KEP that you can check out on the Kubernetes community GitHub repository that will help solve this in the long run. Yeah. Yep. Yeah. Uh-huh. Secrets? Yeah, or something like Vault or anything, any typical way of managing those things. You could also use our secrets manager, any way that you would standard do this, because they're just applications for the most part. Yeah. Anything else before I move on? Cool. All right. So this is my big call out. If you are a partner in here, I saw a couple of hands. If you deploy anything, storage, databases, anything that gets deployed into a customer's account, start thinking about this. It's a very interesting architecture that you can actually start building on top of. You can make sure that your applications are highly available using this control loop. So I really want, and even from the customer's perspective, your applications can be better by doing it this way. There's ways that you can extend this and extend Kubernetes to make your applications more highly available. And I really believe in this. So please start doing this. Please start looking into operators. Please start looking into the like sample controller project off of the Kubernetes org. They're all great resources. Internally, the functions that allow you to do this are very simple to work with. You can do it from Python. You can do it from Go. You can do it from Ruby. You can do it in anything you want. So start looking into this because they're one, fun to develop, but also really helpful when you're actually working on operating large-scale clusters. Any of this automation makes it helpful. Cool. The last thing I'm going to talk about is security. So security, as I'm calling out here, is day 0. And there's some basic things that I would like to make sure that we're starting to instill into some of your clusters. So first off, basics. How many of you are already deploying a way of handling network policies or network security? Cool. There's a few hands. This is the basics of network security in here. What we're saying is I want malicious user to be able to access the front-end application or not be able to access any of these resources. Or from this could also go from, say, for instance, the payments service to the front-end service, or from the user service to the store service. Any of those connections internally in your cluster you can do using that. Now, I'm going to start with, in general, security is layered. How many people are doing something about Host level security. Raise your hands. Are you running agents, things like that, to basically scan those and make sure that they're hardened images? Yeah? If you're not, start looking into this. There's a lot of tools that will help you. You can run agents. You can run these as daemon sets. You can run them directly on those nodes. You can deploy them in there. Things like Trend Micro Deep Security will help with this. There's a whole bunch of other tools that will make this possible. And I'm calling out that it's layered here because we're going to add in some more things. Network security. Start looking into network policy controllers. This is a core Kubernetes component. Tools like Calico by Tigera, they will allow you to actually implement the network policy manifest that Kubernetes allows you to deploy, and it will allow you to automatically set up that pod A can't talk to pod B, or pod C can't talk to pod A. And it's very simple. It's just a YAML manifest file. You can manage it via, again, Flux, GitOps, however you want to do this, your CI processes. You can deploy all those in that. So start looking into these because they're very helpful, and you should be doing this because there are still ways that things can get through these layers. On top of that, how many people are scanning their images? Cool. So those of you who aren't, are you being able, or do you have some verification at all that says that there isn't a vulnerable package in those containers? That open source package from NPM didn't just inject malicious code, what was that, this week or last week or so? Or many times this whole year? Check these things. They're very important to do because we're in a world where we're now using a lot of open source tools, and it's impossible to check the internals of all of these things. One package, I think, what was the recent call out? I think it was like React has 1,000 dependencies. That would be impossible to check all 1,000 dependencies and make sure that somebody's not Bitcoin mining off of your servers. So do this. And the last thing is the application. This is more from the perspective of that same exact thing, managing those packages, managing everything that's inside of those. So host and container, very important. Application, incredibly important. And network, make sure that those applications can only talk to who they should be able to talk to. So Kubernetes basics, please start using Kubernetes RBAC. If you're not, EKS, as it currently stands, implements this for you. It automatically sets your cluster up. If you're not deploying a 1.7, I think it's a 1.6 cluster before, start upgrading because we added RBAC in 1.7, and it's a very important component that allows you to segregate who can actually access those resources. Deploy things like pod security policies. Pod security policies would basically say that any pod that gets deployed into your cluster has to adhere to these levels. Don't run as root, for example. Always specify who that user actually can be. And then the last one is network policy controller. Again, I was just talking about this. This is very important, that network security, really stopping people from being able to access other applications that they couldn't. Because chances are, security is basically just implementing as many stop as you possibly can to stop people from doing malicious things. And hopefully something doesn't happen, but at some time there's going to be some issue, and you want to be covered. So please start implementing these things. Quick demonstration, it's actually not a demonstration, but quick preview of what this looks like. CVE scanning in containers. It's very simple. There's a lot of tools out that do that. There's partner products that you can pay for that will give you really rich UIs and tools that will help do this, things like Twistlock and Aqua Security. You can implement these in your actual CI processes like this. Or if you want to and you like playing with open source tools, there's even things like Claire. That was originally by CoreOS. I think they changed it to now Red Hat, but it's probably still in CoreOS's repo. You can deploy that directly into your CI process just like you would any of those others and get a rich set of vulnerability scans against your images, and it makes it really easy for you to start implementing these. And just like what I was talking about around CRDs and control loops and so on and so forth, you're implementing automation that will help protect you later and doesn't implement a hard stop that would frustrate your developers or even you, because it's not a manual process, and it makes it really easy. That's it for now. I have about 15 minutes to answer questions. I'm Chris Hein again. This is my email. You're more than welcome to email me anything you want. Also, you can hit me up on Twitter. I'm Christopher Hein, and I've got 15 minutes to answer questions. Yeah. On the worker node, so the worker node's still in your account. So I would be implementing something on your side as well. We're going to be protecting the control plane nodes, but you still own those worker nodes that are in your own account. So I would be implementing something from that perspective as well. Yeah. Other questions? Yeah. Yeah. I could pull one up on my own machine. The documentation has pretty rich examples of pod security policies. I would just check out the Kubernetes docs for those. There's a lot that you can actually secure with those, and it spans across any pods that you actually want it to. So, yep. I don't have them off the top of my head. Give me 1 second. Let me pull that up for you. So things like the GUID that you can actually run as, you can control. The pod here. I'm just going to take you over to the Kubernetes Dock. So these are some of the basics that you can actually control. So you can say that containers cannot run. The containers can't run as privilege mode. You can say they can't run as host networking. You can control this all on a global basis across your whole cluster. And it's just a Kubernetes. It's just a manifest file. That looks really simple. I think they have a full example lower. Where is it? Looks like that. So you can set SE Linux rules, your supplemental groups, your run as users. So you can say run as anything. So there's a lot of components and controls that you have with those pod security policies. Yeah. That's a great call out. Yes. So the question was, with the service operator, is the data actually stored in etcd, or do you have to spin up your own etcd for things like you do with something like the service broker? You don't. Out of the box, all of that data gets stored directly in the control plane's etcd because it's adding a resource into that directly from the API server. So you're only ever talking to the Kubernetes API server. Architecturally, behind the scenes, with things like with the service catalog, what's really happening is you're running a secondary web server inside the cluster, and all of the commands that you send, even though they look like they're going to the Kubernetes API server, they're actually getting relayed down to another web server that then has to re-implement a lot of functions. That's one of the reasons why things like RBAC aren't automatically applied into those kind of hookups. Yeah. Yeah. Yeah, so the question is, an operator is basically a CRD. It's a CRD in a pod. So the pod is what's actually managing that whole control loop, and then the CRD is what it's supposed to manage in itself. You would write your own. You would write your own. Yeah. Yeah. Go ahead. Okay. Some of it, yes. So the question is, they're having problems updating CRDs. So there are new functions within Kubernetes 1.11 and beyond. So I haven't started implementing a lot of those functions yet. But there are new functions where CRDs have native support for versioning. So that's been released. I will be upgrading as soon as we get EKS to 1.11. Because I will want to be actually supporting those kind of structures and being able to have multiple versions. As of right now, the operator's only been released in October, so it's still it's in an alpha state right now. But it's, yeah. Cool? Yeah. I'm not sure, actually. So I don't actually technically work on the service team, so I don't know the full roadmap for it, unfortunately. Yeah. Yeah. I don't know the code deploy roadmap, but you can actually deploy using Lambda functions. I think we have a reference architecture out there where you can use a Lambda function directly from code deploy to deploy into EKS. So. Cool. Any other? Oh, yeah. So the question is, do I have any plans to remove the CloudFormation? I don't. So one of the things that I would do if I actually had to remove that is I have to re-implement a full scheduler. And if you've ever followed along, Chris Nova has a great document about some of the learnings that she had while developing COPS for AWS, and things like API limits. There's a lot that goes into it that I can get out of the box directly with CloudFormation. So there's no plans currently. The other side of that is we already have the definitions spec'd out, and I can code generate those directly off of those. With that, the way that it's structured, and when most people ask that, is because they've had maybe a difficult time or they're not interested in really managing CloudFormation. The operator is actually handling it 100% for you. And you really shouldn't be mutating any of those CloudFormation stacks after they're deployed from the operator. I tag all of those in a specific way so that you're not supposed to. Because the idea behind the operator is let the automation and the state that you store in Kubernetes be that desired state. And have all the updates get pushed back into etcd so it continues to be that desired state of the controls. So yeah. Yeah. Huh? Mm-hmm. Yeah, so operators can look a little bit more scary or look like they're harder to manage. I guess that's fair feedback. It can feel like that because you're having to learn a new construct, right? So instead of just learning pods and deployments and so on and so forth, the difference though is from an integration perspective, you can make them more advanced. Which is why we structured around that, because you can say that, for example, in mine. What we actually have, when we deploy that CloudFormation template, I'm also setting up an SNS topic and an SQS queue. And all the events from those stacks are getting submitted into that. Now, that's something I couldn't do directly in itself. Like, I'm able to manage all of those resources directly from the operator, and I can continue to scale those things out, which isn't something that I would actually be able to do using a pod, unless I had an individual container that managed DynamoDB, an individual container that managed those S3 buckets. So it really actually does make it easier. It's just a little bit of a mindset change around what you're storing and what you're managing from Kubernetes. Yeah. I think there's one other question. Yeah. Yeah, actually. So just like you reference a service account from a pod, I have two keys inside the operator that allow you to reference a secondary template. And I actually have a CRD around CloudFormation templates. So you could deploy a CloudFormation template into your cluster, and then you can reference that CloudFormation template like you would a service account by specifying the namespace that you want it to be from and the actual name of the resource. And it will apply using that CloudFormation template. Any other questions? Yeah. With EKS? We actually do support it. We announced that, I think, in September of this year. So we have an AMI, and I think it's based on the NVIDIA drivers, if I recall correctly. Yeah. Yeah, we definitely we did release that. We did release that, and I think, like I said, I think it was in September that we released support for that. And we have, just like we manage our AMIs through Git, if I recall correctly, we have a like a subdirectory in that repository that has the NVIDIA based AMIs. Cool. Any other questions? Yeah. Sorry, there's a light right in my eye. So yeah. I don't. Not directly. Indirectly, you can. So let me actually show you what this looks like. So in the actual code, how they're referenced, because you can do that. So what I've done is I've actually kind of abstracted away the concept of ARNs. So when you reference something, you actually reference it by the CRD name. AWS Service Operator. Cool. So this is the project on GitHub. If you check out some of these model files, you can actually see how this works. So for example, in the SNS subscription, not topic. So in the SNS subscription, what you actually can do is I'm using Golang templating in my model files to actually reference other things. So you'll notice in here on line 23, we have call helpers.get SNS topic by name. So when you pass in a name of an SNS CRD resource, it'll actually go through and look that resource up and then grab the topic ARN that came from the outputs and use that as the parameter that it gets passed into the CloudFormation template that backs this. So there is some way of actually meshing two components together. And a perfect example of how this actually fully works is in examples. We have this SNS SQS sub manifest file. And you'll see that we basically have an SNS topic that's just called example SNS topic. We have a queue that's called example SQS queue name. And then down here, I reference those directly by the names. And it will go and do that lookup for you. So it'll go and just basically try and apply 3 stacks, one for the topic, one for the queue, and one for the subscription. And the queue and topic will start provisioning. And the subscription is going to fail because it doesn't know the full ARN yet. And when it fails, it will do a rollback. And the operator will delete the stack for you and then try and reapply it. And then it'll continue that loop until it succeeds, just like Kubernetes does in itself, that control loop that tries things and then goes into a back-off loop and eventually will start erroring on you. But in this instance, what happens is that queue and topic come up, and then the subscription succeeds. Does that answer the question? Cool. Any other questions? Yeah, one in the back. Yeah. Yep. So just like any other resource, you could do kubectl delete -f with the manifest file name. Or because they are just available via kubectl in general, you could just delete the actual resource. So like in here, because I had that DynamoDB, there we go. So because I have that DynamoDB table, I could just do kubectl delete or not -f, Dynamo, and then say Dynamo resource or Dynamo table. And this is actually going to delete. And what that actually does is it calls delete stack on the resource for you and makes sure that that doesn't happen. And there's some other nice things in here. That control loop that I've been talking about that is really useful. If say, for instance, somebody that didn't know anything about the operator, didn't know what you were deploying into it, goes and deletes the CloudFormation stack, that loop is still running. And so it's going to try and reconcile periodically for you and say, hey, somebody deleted this stack. Let me just go recreate it for you. The data will be lost in some of these like stateful services, but it will still try and reconcile that state. And you, because it uses CloudFormation behind the scenes, you can technically put locks on those, but that's more of a manual process. Cool. Any other questions? I have about a minute and a half. Yeah. Yeah, so if you were deploying Prometheus, how would you manage that? Yeah. So that's a great question. What are the best practices around managing stateful services using operators? I would still rely on typical ways of managing state across any application, because behind the scenes it's just a pod. So check out tools like Portworx that will allow you to do like a software-defined storage on top of your cluster and have that shared, or things like Amazon EFS to basically manage that state across the cluster and share the state for you. Yeah, typical ways that you would do state in any kind of containerized environment. Cool. Got time for one more question? All right. Cool. Thank you, everybody. Again, Christopher Hine on Twitter if you want to talk.